Hello everyone, and welcome to our next section in Unit 1. We're going to talk about John Dalton. He was an English scientist who lived from 1766 to 1844, and he was also a teacher. That was how he earned his living. And he's best known for his atomic theory. That was his main contribution to the world and how everyone remembers him. There are about 5 points in Dalton's atomic theory, and this was quite a new idea back at the time when he came out with these ideas. The first idea is that elements are made out of atoms. That's the first point in his theory. The second point in Dalton's atomic theory is that all atoms of a given element are identical. Now, you might laugh and think this sounds silly, but it did need to be stated because this is not how everyone used to think. If we have a carbon atom, it's the same as the next carbon atom because they're the same element. So their atoms are the same. If we have a nitrogen atom, it's the same as the next door neighbor nitrogen atom. They're just the same, even though that may not have been what everyone thought. Helium, if we have a helium atom, another helium atom will be the same. And then the third point Dalton came up with is that the atoms of one element are different from those of another element. So if we have two atoms that are the same, they are the same. Two elements, their atoms are the same. If we have two different elements like carbon and hydrogen, their atoms are different. Here, if we see a copper element and lead element, well, their atoms are different because they're different elements. So the fourth main point in Dalton's atomic theory is that atoms combine to form compounds and that a given compound has the same relative numbers and types of atoms. In essence, what that means is, let's look at this water molecule, okay? It's a compound that contains an oxygen and two hydrogens. If we look at another water molecule, it will also contain one oxygen and two hydrogens. If we look at another water molecule, it will contain one oxygen and two hydrogens. So it will contain the same types of atoms and the same numbers of those types of atoms from one compound to the next when they are the same compound. So down here we have magnesium chloride. Magnesium chloride always has one magnesium and two chlorine atoms. And one compound of magnesium chloride will always be just that, and it will be the same as the next compound of magnesium chloride. We call that the law of constant composition. From one compound to the next, we have constant composition. The last main point in Dalton's atomic theory is very much just restating the conservation of matter. He said that atoms are not created or destroyed in a reaction. They're just regrouped. And we know that, we'll take an example here. If we have two hydrogen molecules, there's two hydrogens there and two hydrogens there in each of those molecules. And we take one oxygen molecule that's diatomic. It has two oxygens bonded together. And we have a chemical reaction taking place and form two water molecules. We have rearranged the atoms, but we have not created or destroyed them. Over on this side, we have 1, 2, 3, 4 hydrogens, and over on this side, we still have 1, 2, 3, 4. On this side, we have 2 oxygens, and over on this side, we still have 2 oxygens. So that's important to remember that we never create or destroy atoms, we just rearrange them. So a quick review of Dalton's atomic theory. Elements are made of atoms. 2, atoms of a given element are identical. 3, atoms of one element are different from atoms of another element. 4, the law of constant composition here where we have a compound has the same relative numbers and types of atoms. Number 5, atoms are not created or destroyed in a reaction, just regrouped, the law of conservation of matter. Now, I did not make a page giving you ideas for advanced proficiency. I was hoping you could come up with some wonderful ideas on your own. This is sort of a tough one to think of above and beyond as far as content, but you're welcome to dig further into maybe historical information, what kinds of scientific thoughts were happening at the time Dalton was alive. What were his contemporaries doing? How well were his were his publications received? Were they received well? Were they laughed at? You can just look more into his life and other contributions he made to science and other contributions some of his contemporaries were making and things that were going on. Those would be really great ideas. So I can't wait to see what you can come up with. We'll see you in class.